Hello everyone, welcome back to the privacy preserving machine learning, which is also known as federated learning, what, why, and how lecture series part 2. I will first try to give a brief recap of what all we have covered in the part 1. So basically, we started with machine learning, explaining what is machine learning, how it tries to what it does. Basically it tries to convert experience into knowledge through a process called training, which involves a model and input and output data, where we give input data to a black box model that can be anything, model, algorithm, or any function approximator, which gives us a prediction output, but we ourselves we have a ground truth of the expected output, and we try to reduce the Euclidean distance or the error between the prediction output and the expected output, which we call it as a loss function. And we then compute the gradient of the loss function with respect to the predicted output as a part of the backpropagation algorithm or gradient descent method. And then we propagate that gradient backward through the layers and calculate the gradient of the loss function with respect to the weights and biases of each layer of the machine learning. And then we update the new weights as given by old weights minus eta times the dou L by dou W. Eta here is the learning rate. We do this process until the loss gets converged to a local or global minimum depending upon the convexity of the loss function. Then we discuss the black box part, what all models it can have, basically depending upon the type of machine learning, supervised, unsupervised, and reinforcement learning. Then we discuss the different types of tasks involved in supervised and unsupervised machine learning with respect to the continuous and discrete data space. Then we detailedly discuss the task, based on the task, what all models that can be possible, starting with image classification, where we took an image of a dog and explained the task and the corresponding models involved in it. Then we moved on to detection or the localization task. Again, what it does, and what all the models involve, single stage and double stage two stage architectures, why it is the reasoning and all. Then we moved on to segmentation, then object tracking, sequential tasks, generative AI. And then I have concluded the part one saying this all comes under something called model centric AI, where the aim is to develop more accurate model than state of the art models than the previous models on publicly available data sets. Now, in this part two, we will try to focus on the input data. Basically, this would drive us for the rest of our lecture series. Basically, how input data matters and what role it plays in the entire machine learning process. So basically, input data or input to any system or machine in general, or process in general, irrespective of the machine learning, is very important. You give good input and expect good output, right? And you give garbage input and you can't hope that the process will run smooth. So input data plays an important role in any process or a system. So we'll start today part 2 of the lecture series from here. Input data, what all it involves, and why it is important. And for machine learning model, if you give more and more rich data, the model will be more and more accurate. So when I say rich data, there is some there it has to meet some criteria to call to be a rich. Now we'll discuss what is that, what are the properties it has to be met. So to start with, let us assume that you are starting a new project altogether, where there is no data set, and you want to collect the data set all by yourself, do the processing and everything. So first thing that is involved in the input data uh, preparation is simple thing collection, or if you can't collect, you try to generate some synthetic data. So generation, and from various subjects you may try to prepare the data, right? Second is you try to pre-process the data. It's called pre-processing step. Third is annotations or labeling. Again, this is specifically for the supervised ML case that we discussed in the previous part. And fourth step, final step, is storage and sharing, which is again a very important step. Now we'll go step by step what are the challenges involved in the each of the steps, and what are the existing methods or methodologies currently available to overcome those challenges. So first, in the data collection and pre-generation or preparation stage, the challenges here can be unavailability of data. Basically, for example, in a domains like healthcare or medical, there can be a rare disease or a cancer where only 1% of the entire world population has that cancer, and it's very hard to get that kind of 1% of data. So in some cases, such cases, we may not get any samples or any type of information about that data. So it is a very common real world challenge. Second thing is we may get some data, but that would be imbalance. When I say imbalance, for example, let's say you are collecting 5 class data: C1, C2, C3, C4, and C5. This is a histogram, and the y-axis represent the frequency of the data samples you collect. So in some cases, you may get one class data to be highly dominant, we get more samples, but for other classes we may get very less samples. So you can't train a machine learning model using such kind of imbalanced data, which leads to overfitting and biased models, which you don't want. So this is another challenge. The third challenge is the quality of data. Yeah, good, we'll get some data, maybe a balanced data, but what about the quality? So quality always is very important. As I said, if you give good quality input data to a machine learning model, you'll expect good output. The model will be trained in such a way that it highly learns the features of quality data. The fourth point is again quantity. In this, we may again get a balanced data, some kind sort of balanced data, but those are very less. As I said, machine learning needs good amount of good number of samples, is good amount of data. The more and more data you give, the more and more better models you can expect. So in case you are getting balanced data, good quality data, but there are very less, very few. So then again, this is a issue when you have less amount of data. So quantity is again a challenge. Now, having understood the four challenges, unavailability, imbalance, quality, and quantity, there are some available techniques that can be applied to overcome these challenges. So first is data augmentation. So basically we try to create more data within the data we have by using something called augmentation techniques. For example, we have the same dog image that we were talking about, right? And we try to we try to rotate this image and create a new image. Again, rotation again depending upon the angle of rotation, how much angle you want to rotate. Based on that, you can create that much amount of data, that many number of dog images. Then scaling, then translation, and so on. So you can try to replicate the data points with whatever data you have, and then augment using augmentation method. You can create more data.